assess how we actually determine if soil is polluted or not, and using different indexes or different indicators. By multiple pollution means it's multiple elements, multiple contaminants that are included. We focused on some main metals you will see in your database. It's like lead, arsenic, cadmium, mercury, zinc, copper, several several heavy metals that are found in Moscow. And the key, why we're doing this assessment? Well, the key of to an effective assessment of soil contamination with heavy metals is the use of suitable indexes or indicators of pollution or contamination. You know now the difference. It can be regarded as a tool and a guide for comprehensive geochemical assessment of the soil environment or soil environmental state. There are different indexes that are accepted around the world, and we will focus just on the most common ones here because there are way more than that. They are categorized into single indices or multiple or complex, total complex indexes. So we'll see example of each. The single indices as indicators of soil pollution comprise of numerous indices such as geoaccumulation index, enrichment factor, pollution index, contamination factor, threshold pollution index. These indices are calculated from the contents of each individual metals in soil, and they have been used for the classification of soils for several classes according to the degree of pollution. So I'll walk you through a few examples here. So here is the first single pollution index. It's pollution index, just like that. It's simple, PI, calculated, as you see, it's a concentration of a metal. You will have your examples divided by the geochemical background. And in this case, we're using given by geochemical background. You see here some values for nickel, copper, zinc, and some other metals. So we will use those values. Sometimes indexes use or propose to use geochemical values that are contained or were collected in a local environment, let's say just for Moscow, someone would do it, or sometimes we use literature for that. So that's where you read about the indicator or the index and see what they're using, and then you find the data according to this. So for this one, we will use the values that they provide us as references. This PI index is an index that can be used to determine which heavy metal represents the highest threat for soil environment. Another one is the geochemical index. This allows the assessment of heavy metal soil contamination based on the ratio between the current content of heavy metals typically in topsoil and the content of heavy metals in maybe lower horizons of soil in the bedrock and the parent material of the soil, or in specific geochemical background for that metal. To assess the degree of soil pollution as well as possible impact of anthropogenic activities on heavy metal concentration in the soil. So this is why we use this index. I guess here you see it's again heavy metal content divided by the geochemical background and multiplied by this constant factor. And we use a logarithmic scale. All of these formulas you will be able to do in Excel today. You will learn how to do it in Excel or Google Sheets. And you can also see the interpretation, what these values mean, if it's less than 0, 0 to 1, and so on. So based on the number that you get per different land uses, you will see that Excel or Google Sheet contains several land uses for Moscow. And you will calculate this index, some of these indexes for each of the land use, and then using this interpretation guidelines, you will say if the soil is polluted or not, contaminated or not. Here's the enrichment factor, is the measure of the possible impact of anthropogenic activity on the concentration of heavy metal in soil, to identify the expected impact of anthropogenesis on the heavy metal concentration in the soil. The content of heavy metals categorized by low variability of occurrence, and it's used as a reference in both in analyzed values and in background values. Typical reference values or elements, usually it's iron, aluminum, titanium, calcium, manganese. Here we again use the concentration, reference concentrations that I just mentioned, and background values. And then you use the guidelines to figure out if it was contaminated or not based on this enrichments. So now let's look at a few total complex pollution indices. This is where we take, you see here we only had a particular heavy metal concentration. So single means we only take one. So it's just, we calculated for lead, we calculated for arsenic, we calculated for mercury separately. But when we want to consider multiple pollution, we want to take into consideration several metals. And here we'll see what indexes exist for that. For example, Nemerov pollution index. Don't get scared by this formula. You will figure out today how to do it in Google Sheets. Olga actually made a formula for you in how to type it in. Google Sheets, Excel will do all the work for you. You just need to know how to put it in. This Nemerov pollution index allows the assessment of the overall degree of pollution and of the soil, of course, and includes the contents of all analyzed heavy metals. So you will take into consideration all of those metals that we have in our database today. And again, you see the guidelines how to make interpretation for that. Another one is pollution index average is used to estimate soil quality. You see here we need to use prior calculated pollution index that we use is in a single pollution index calculation a few slides back, and a number of studied heavy metals, and we use a summary function to make the calculation. And the interpretation is very easy. If it's less than 1, 1 to 3 moderate, more than 3 is heavy. PERI is another index that I like to use because it shows the, this index covers various environmental effects such as toxicology, environmental chemistry, ecology, and can evaluate ecological risks caused by heavy metals. And here we'll need to consider enrichment it's a toxic response factor and single index of ecological risk. I will show you how we do this, what formula goes for that also in the next few slides when I show you example for New York City. So here we see that we use the T, it's toxic response factor for individual metals. So this scientist Hackinson in 1980 published a paper, proposed these values that you see here on the slide, and we will use these guidelines, these values as our toxic response factors, and only insert our own PI in this formula to calculate specifically for Moscow. But everyone who would like to measure, calculate it in even other countries, they will always refer to his toxic response factor that he derived through his research. And again, here's the guidelines, what these values will mean. Because once you calculate today different indexes, we will ask you to calculate at least 2 single indexes and then 2 complex pollution indexes, then you will need these guidelines to tell us what it is. Is it polluted, is it not, and then compare between different functional zones. Here's a really cool one. It's abbreviated as a MERMQ task index. Is a really suitable tool for assessing harmful impact on soil and was first applied for evaluation of sediment quality with respect to the evidence of negative effects. Chemical concentration of metals corresponding to the 10th and 50th percentile of adverse biological effects. Recall the effects range low, and it's abbreviated as ERL, effect range low, and the effect range median, ERM. There are three ranges in chemical concentration where adverse effects rare if it's less than ERL. Occasionally, if it's in between ERL and in ERM values, and frequent occur if it exceeds ERM values. The value of ERM is used for the calculation of this index, and this can be applied to identify and prioritize areas with potential hazards with respect to quality of soil. So we will need again the concentration of our metals, summary, you see the sum function, the number of course, and this given to us effect range medians or range lows. Here's the formula we will need to use in our calculations, but it will be repeated in the guideline as well. This one we don't require you to calculate, but to show that there's another cool contamination security index is informative about the intensity of concentration of heavy metals in soil. To calculate it, we need the effect range low and the effect medium range as in the previous index. This value is already given to us, and this index is helpful to determine the limit of toxicity above which the adverse impact on soil environment is observed. So this different indexes have a different applications. Sometimes it's more for toxicity, sometimes for biological adverse effect, sometimes it's to show ecological risks or just anthropogenic effect, because if it's way higher than the background, chemical background of the city in our case, then we know there's some human impact. So these indexes have each of them has their own unique usage or application, and it's important to know what they are used for, and then based on that value you can say if soil contaminated or not. Sometimes you may find that you get different results, but because they focus on different things. So some index may show soil is polluted, another one may not, because they use different variables. This is really commonly used in Russia, and you can see again we use the concentrations of heavy metals in soil versus background concentration, and we find a summary of them using these calculations, and then based on the value that we get on the right side in the table, we would use it as a reference to guide us about our decisions, if soil is contaminated or not, and what we should do about it. Russian soil standards, again, as he mentioned, is much lower than anywhere, I think, in the world. Like for lead, I work a lot with lead, so I'll give you an example. In the States, it's federal standard is 400 parts per million. 400 parts per million. In Europe, this concentration varies with like 100, 150 parts per million. In California, in the US, it's 80 parts per million, and here in Russia, it's 32, right? So it's like really, really a big difference. But we never had such a big like industrial input in Moscow, and that's why we don't have such a really huge concentrations as in other countries. Of course, there are towns in Russia where like mining towns will have really high concentration of some particular metals, but those are mining areas, naturally the rocks will be enriched in those metals. So you can see how small these values are. Arsenic is like 16 or 19 in New York or New Jersey. In Moscow, Russia, it's only 2, so quite low concentrations. In your summary, you can also make average if you want for different metals, play around from the database and see what concentrations you get for some particular metals, if not all of them, in the different functional zones, and then you can compare and see which ones had a high concentration of metals. I think you'll be very interested. Here's an example actually that Olga put in from her research, it's you can see the concentration of like arsenic. This is probably in Moscow. Like cadmium, copper, you see that the concentrations vary, and some of them are exceeding the thresholds quite by several factors. Here's American soil standards. Again, Professor Chen walked through you this different concentrations. We have different values, and depending on the use, if it's residential, a non-residential area, commercial area where people garden, and we have different concentrations of metals that are permitted. You can see for New York State, this is like we really have a high concentration of metals, and yeah, it's like really heterogeneous soil. Concentrations are really really high, and you see New York State baseline is really low, but we have very high concentration in the soil. That means that we have anthropogenic impact, but just comparing to the reference that found in rural soils around the state. And here's the 400 parts per million. This is from my research that Professor Chen mentioned that we did the study like gardens in New York City, urban locations in community gardens or home gardens. This indexes were applied to those samples that we analyzed, and contaminant factor, we found concentration over the background value. We used New York State, I think, values, rural areas, and then by just finding, we had like, I think more than 700 samples for this. We found different concentrations like mean, minimum, maximum values. I was able to look at the degree of contamination. So which one has the highest concentration, and then like the least. You see the nickel is the least, it's 1.24. And minimum is 0, so like, or maximum, so it's not as bad compared to lead or cadmium. So these contaminant factors also can be used to see what is the predominant contaminant in the city. Quite useful and easy to calculate. This is a single ecological risk. In our case, it came mostly from lead and cadmium. You see quite high concentrations, although this is the log scale, right? It's not linear. So if it was linear, it would be a little bit different, but this allows us to see how many outliers we have. Again, highlighting the impact of humans, anthropogenic impact, and some emissions or deposits of heavy metals from the past. And how we calculate it, this is what we use. We use contaminant factor that we previously found. We multiply by the toxic response factor that I mentioned a few slides before from Hackenson in 1980. He published these values. So we all use those values to make the calculations. And then to represent the value, it's like sometimes you get the number, but what it means. So this is how you could visualize your data by putting some box plots like this. I have, or like table here, and highlighting different colors to guide the reader that it's much easier to follow. And the box plots are useful because it shows you distribution, and you can compare between different metals. And then if you just place the categories instead of just like writing them on the side here, you can place as guidelines and get a really nice box plot. Or maybe I'm subjective because I made this plot. Another way how to represent the data is to use potential ecological risk index, as PERI index that we also covered. We got the values by summing these previous values of ecological risk index. Just sum up, and then I made the distribution, this pie showing the distribution. And in this example, we see that cadmium is actually predominant. There are way more soils contaminated with cadmium than followed by lead. So this is quite interesting to see what distribution we get. And what is really important for our case in New York is that, or like even in the States, we often understudy cadmium. It's not very commonly studied, and mostly we focus on lead and arsenic. So indexes like this show us what we're missing. And now this index shows like, okay, cadmium is actually important and we should focus and study on it. We should not forget. And this is the pollution load index. This is used by multiplying all the contaminant factors from previous calculations. Doing some stats, I found the samples that we used. We had 126 samples for these four metals. And for all the samples, there were soils that exceeded 1. And this is a threshold for soils being polluted. If it's less than 1, it's not polluted, more than 1 polluted. So you can see we had maximum like 64. It's really, really huge value, and minimum 1. So like all of the samples were contaminated. Not even 1 was lower than not polluted. So this also shows us there's a constant pollution load. Evaluate soil contamination in Moscow City, using different indexes that we showed you here. And you will need to compare it per different land uses. You will see in a second, I will share with you Excel file or Google Sheets, the same thing. I use it interchangeable. It's not the same thing, but it functions as very similar. So you will see we have different sheets with different uses, and we will calculate the same indexes for all those uses, and then you need to compare those values. We only require you to do 2 simple indexes and 2 totals, complex indexes for practice, and get really good at this within 1 hour, 15 minutes. You're very welcome to try all of them at home. If you, reach out on Facebook if you want to ask more questions, or if you do it at home, I'll be happy to share. But what for now, we will I will walk you through a little bit what we're going to do using the protocol, Excel or Google Sheets. And again, based on the results you will get, you will need to make interpretation by the values of the calculated indexes and by functional zones. You will need to write a conclusion based on that. You can just write it in words like a paragraph, or if you want, you can make a table or a graph and submit it as a Google Sheet, or if you want Google Word document in the folder. Object, this is the sample distribution of data points that you will see in the Excel. In Excel, you only see this. This is what you're going to see. So we have ID, don't worry about it. It's just the number of a sample. There are 100 samples, 20 for recreational areas, the different color is green, 20, or recreational, residential is 20. You can see the color here, public 20, industrial and traffic zones. We also have this functional zone here represented in Excel. Olga separated them in different sheets. So you're going to see 20 samples in one sheet, 20 samples in another sheet, according to the functional zone or land use. I use it interchangeably. And you will see pH or texture, because for Russian standards, it's important to consider pH or texture of the soil. Typically, soil with heavier content, with more clay, would have a high concentration of heavy metals. So that's something you may observe. You can do the comparison. And we are going to look at arsenic, copper, zinc, manganese, nickel, cadmium, lead, and mercury. So you have 7, no, even 8 heavy metals, which is really great. It's a really good range. And the samples are nicely distributed around Moscow, so you're going to see some differences. And what you're going to do with this data, we don't require you, of course, to create maps or these diagrams, but this is to show what potentially can be done once you work with these indexes. They can be represented in different ways. The simplest form is to have a table. You already saw my box plot. I think it's similar. It's another box plot, but similar concept. It shows the distribution per each metal in accordance to the guidelines, if it's at moderate risk, if it's low risk, high risk, and so on. You can see this. This is for New York City. This is diagrams for Poland. You see how they represent is like using the bars to show which part of the city is probably contaminated. Yeah, look, they use this contaminant security index and shows how that is the highest in this part of the town. We could also make some line graphs and see the different indexes where represent just the lines. And I don't know what's, gosh, I can't see. So yes, just another way to make the representation is using the lines and see how it changes maybe over time or different samples wherever your x-axis is. And another way to make representation of on a map, and this is Olga did this map. This is index for like cumulative index for used in Russia a lot. The one we saw before with permissible levels, and this is what we get if we map this index. It looks really neat, right? Like we see some hotspots with like high concentrations, and we know by this like what areas we need to target and which ones are most contaminated. So this is how indexes are used and applied, and how we can represent them. We don't expect you again to create maps or diagrams. If you can make, if you do the calculations, you're able to see trends and you make interpretation of those trends using the guidelines that are provided. The categories, more or less this and that, that should be enough. If you want, you can create a couple simple diagrams to play around, and that would be great. Okay, so now, do you have any questions before I walk you through the methodology? You can speak up or write in chat. No? Okay, I just want to make sure you're here. Raise your hand. Are we all here? Okay, Maria's here.
Yes, Trini is here, Sumi is here.
Yeah, Olga, good.
Good, yes, we see you. Okay,
Good.
Sandu is here.
Okay, good. So let's, I share with you this. This is what you're going to, oh, you can actually open it right now too. I will send you a link in the chat. Can you guys all access this drive? That's where we're going to see what I'm showing you right now. This one. So this is the folder you're supposed to see. Results folder, it's where you will get your results, where you will upload your work. This PDF file is the presentation, so you can use it as a reference for interpretation if you want. It's exactly what I just showed you. And here's the data file. I'm going to walk you through this a little bit in a second. And here is the protocol. Protocol, you will see background information, just a little bit on contamination, what I just told you about the map, how the samples were collected. It's from 5 different functional zones, 100 points, different metals. You will see this database. The task will be, we need to open this file in the Excel file that you got in the drive right now. You can open it in Google Sheets and make a copy for yourself. I'll show you how to do it in a second. And then I will give you an example how to calculate one of the indexes, and then you will take it from there and do it on your own, following the guidelines below. Again, the end product is 2 simple and 2 total complex indexes that you need to calculate and make interpretation. You can just write a paragraph showing your results and make and tell your conclusion if it's polluted, not polluted, and what differences you see between different functional zones. and upload in the same folder is in results folder that you see. So here's the example. I'll walk you how to calculate this. The first one, we'll just do single pollution index. You saw it already in the slide. It's concentration of a metal in milligram per kilogram or parts per million. It's the same thing. Divided by the geochemical background contents that were used in this paper. So we'll use these values for our purposes as well. I will show you how to do the calculations. And we will just follow this simple guideline, and then whatever value we'll get, we will compare it to this contamination level. This is very simple interpretation, right? Low, moderate, or heavy. And then you need to work on your own several other few indexes. And we will be here to help you out, but here Olga already put in the formulas that you need to type in, so it shouldn't be hard. Just like, read carefully and don't miss parentheses. That's a key thing. It's very common just to miss parentheses and not, then you get the arrow, but you shouldn't get. So it's all highlighted here. What you need to do, references you're probably interested in. How Google Sheets or Excel work? You can click on any cell and do calculations anywhere. It doesn't matter. Even if you do calculations here and you need to move the, it's not the cell, you just move it and the calculations will not change. The formula will stay the same, the values will stay the same. So don't be afraid to move or to place it anywhere outside of the values. The calculations will not be affected. I'll just start from the top. And let's start to work number one, calculate single pollution indices. PI, to calculate pollution index, we need to divide concentration of a heavy metal. And we have eight, right? Metals, and the geochemical background value. It's already given to us as letter B. So what I do, I click on any cell. I start with the first one. Which one is the first one? Arsenic. So I'll write just PI arsenic. So I know that I'm working in the pollution index for arsenic, so don't get confused. And then I click enter and I go to the second line. See, that highlights me second cell, N2. I hope you're doing the same time as with me, so you know how to do it. All Excel or Google Sheets formula start with equal sign. Google or Excel will not understand what you want to do, how you want to calculate, unless you put equal sign. This is a language, programming language for this program. So start with the equal sign and then do what we want. See here, arsenic, we need to highlight F. 2. So the very first cell. And in our address book, in Excel, Google Sheets, you will see what you're doing. So you can always go back and recheck what was done. So here I see I put the equal sign, I click on F2, and it's highlighted in the cell here, and you see it in the address book. And then I need to divide it by the number. Because we need to divide by the background number. And we already said that it's given to us in this paper, Kabata PNDS 2011, for arsenic, this value is 0.67. So I take this F2 value, I divide it by 0.67, and I get the value. Right? Small trick, this is very like really long digital, right? Like lots of space, lots of decimal points. Let's make it pretty. If you click here, this decrease decimal places. It's in the same on Google, in Excel, and I just click on it and just make it maybe round or just one decimal place. It's just easier to see and kind of visualize. And what I do next, I just drag this down. I take the corner of this. You see, it needs to be exactly at the bottom right corner, and then I drag it down. And I get the calculations. How I know the calculations were done correctly? I can click on any cell and see what happened here. You see, I click on the cell and shows me the formula. So it used the proper line. It used arsenic, the line, it divided by 0.67, so it didn't change. So I already calculated PI index for arsenic. And then I would need to do it for other metals. So next one is, what do we have? Copper. I'll do the same thing. So I label it so I know what I'm doing. I click on the copper cell, I divide it by, I look at the values given in the guideline for copper for the same guy from the same article, and for copper is 38.9. 38.9. I got this small value. I decrease the decimal places just to make it more readable, and I drag this down. Boom, it's done. Let's see, I think we could make it easier if we copy and do it for the next one. Just see if we can easily do this. You don't have to retype. Yep. Okay, cool. So a trick, right? So you don't have to retype it for different sheets, different pages. What you can do, see, like I did this for industrial, just did arsenic and copper, right? You will do for all 7 metals, just like I did. Let's do another one together. So next one is zinc. Pi, zinc. Zinc is what? Zinc is 70. We need to divide by center. So I equal sign. I click on zinc. I divide it by 70. I get the value. I decrease decimal places, and I drag it down. I do the same for all other metals, but you need to do it for 5 sheets here, right? It's time consuming. You don't have to retype this. You can do what, like you can highlight the top row with the name and formula. So you can just highlight the top first row with calculations, copy these lines. I do Control C or Command C if you use a Mac. I go to the next page, public. This is what I had before, so let me just delete it. And I copy and paste it. Control V or Command V. And I want to make sure it calculates correctly, right? So I go and check. Arsenic, 6. Okay, highlighted. Copper, go back. Copper, good, perfect. So it highlighted me correct values. Now I want to drag it down. You will have for all 7, so it will be very quickly. You drag it down, boom, you got all the values. Right? And I check it, it's, yep, zinc, good. And you do the same thing. You can just copy and paste it for other functions once you have all 7, and you will need to drag it, and you'll get calculations for all of these values. Okay. So that's how it's done. Okay, look at this. One of these values is really, really high. Oh, because arsenic is high. Okay. So that's how you do this. And after once you do these calculations, you get the PI, and you may you need to compare it to the contamination level, right? So you may see, Olga, do you have a suggestion how to make it easier? Should we do maximum minimum values to show the range for each function zone, or we should do the sorted?
I think we can calculate average and maximum and minimum, print equal and average and max min.
Okay, so and then we'll go. Okay, so the average I can do like this, average. And you see what I do? I equal right? Do the same thing here. Equal to average, you type in average, it will give you suggestion. You see, it will give you a bunch of different sections. You can click one of them, you only need average, or just type it, open parentheses, and then highlight the column and click enter, and it'll give you the average. I then do maximum values and minimum values. And I will need to do the same thing. Max, simple, highlight. And then I do minimum because I want to be time efficient. So I do these formulas, and what I do afterwards, I just drag them. See, and they calculate me for other things. So, and I want to check it's collected the correct value. Yep, maximum, highlighted this. Minimum, highlighted this. And I got this value. So then you may see what is the contaminant level, right? So like for arsenic, we have average 6, maximum, minimum. Here we in the guidelines, we see that contamination level less than 1 is low. We don't have anything less than 1. And more than 3 is heavy contaminated. So for arsenic, we have average is 6 and you know, minimum was 3. So it's definitely heavily contaminated for arsenic. And you compare the same values for other two. This is copper. For copper, it's not that bad. It's like less than 1, so it is some low, and more, maximum is 7, so it's more than 3. So some of this, it's variables, heterogeneous. There's low contamination, high contamination. You can say it varies from low to heavy contamination. And you do the same thing for all the metals.